Somebody help. I'm stuck in a giant spinning box thing.
Valerie, what are you doing? We still have a math contest that's due in 5 days and we haven't even started.
Yeah, but I don't even know where I am. What is this?
Don't worry, let me explain. To best understand the fourth dimension, we need to look at the geometric progressions of a fourth dimensional object. Take a zero-dimensional point. It has no width, depth, or height. It's just a singular point in space-time. Adding another zero-dimensional point gives us a one-dimensional line, now with the property of length. 2 more points and we have a two-dimensional square. 4 more points gives us a three-dimensional cube. And by following this pattern, we can infer that a fourth-dimensional object, often referred to as a tesseract, would be an object with 16 zero-dimensional points. But how could this exist? How could 2 sets of three-dimensional coordinates be connected without taking up the same space? The most probable answer to this question comes from Einstein's notion that time and space are connected, and that would mean that the fourth dimension is time. Take a two-dimensional character, and although he exists in 2 dimensions, he can only see in 1, just as we three-dimensional beings can only see in 2. If we were to pass a three-dimensional hand through his line of sight, he would never be able to see the entire hand, but rather a progressive transformation of a one-dimensional space. We are treated the same way with the fourth dimension. While we're unable to perceive time as a physical entity, we experience the progressive transformation of the three-dimensional space that we live in, which is caused by time. The same way a three-dimensional object contains infinite instances of a two-dimensional space, a certain period of time contains an infinite instances of three-dimensional space.
The tesseract is a type of 4 polytope, which is essentially a fancy way of saying fourth dimensional object. It is known as an 8-cell polytope, though there's plenty of others with all different kinds of cells, but let's just focus on the tesseract since it's a simple one. Now, the actual visualization of it is very hard to do, and so the picture of it is not good to look at. Instead, we use a configuration matrix, which is a 4x4 matrix with each row and column indicating vertices, edges, faces, or cells, which are its features in different dimensions. And the diagonal numbers all indicate the total number of that feature. For example, the tesseract has 16 vertices, 8 cells, 32 edges, 24 faces. The other numbers also indicate things. For example, the 4 in the second column, first row, indicates at each vertice there will be 4 edges, and the 2 in the first column indicates that at each edge there will be 2 vertices.
Ideas of the fourth dimension were first suggested by Jean Le Rond d'Alembert, and the idea was that there was such thing as a fourth dimension along with the first, second, and third dimension. Later, Albert Einstein expanded on this idea, and he discovered his theory of relativity, which said that the first, second, and third dimensions were length, width, and height, and the fourth dimension was actually time. The idea of the tesseract was first discovered by Charles Howard Hinton, and he wrote about it in his book called A New Era of Thought. In this book, he talked about geometric shapes that could possibly exist in the fourth dimension and how there could possibly be a dimension beyond the first 3 dimensions. Throughout history, many big mathematicians like Riemann or Gauss, for example, drew from these ideas to create their own theories about geometric shapes and bending surfaces. There are many modern mathematicians who are still finding out more information about the fourth dimension and fourth dimensional geometry. One example of this is Carol Uhlenbeck, who is a female mathematician who studies physics and math and bending surfaces and how it connects the fourth dimension and other types of geometry. She's an important figure in the current math world because she inspires a lot of young women to go into the math field and pursue STEM, and she advocates for more women becoming mathematicians. In all, although the fourth dimension is not visible to us three-dimensional beings, it continues to fascinate mathematicians in the past and mathematicians in current modern day.
Wow, that was a really interesting lesson.
Yeah, it was pretty cool. We still have a math contest today, so I'll see you in Mr. Tinker's class, okay?
Yeah. I'll be right there. Wait, I'm still stuck.